Hello, people. Wait, is creeping banana different from stinking banana? What's going on? How many bananas with different adjectives are there? Creeping banana, stinking banana, moldering banana, melting banana. I don't want to turn on emotes because I fear what is going to happen to quality of discussion if I do that. The rant did not start. Nothing has started. We're going to give people a few minutes to show up. Let me turn on some lights. It's getting dark earlier and earlier in the evening. That must be a sign of the apocalypse. Give people 2 more minutes. 2 more minutes. SpaceX is sending private citizen around the moon. They're going to announce this on Monday. Well, that is good. Let's hope it doesn't explode. Let's hope they don't get shot down by the Russian moon base that was constructed in the 1950s. Could I sum up in a few words why C++ is bad for game programming? Because it keeps asking you why. Dude, it's a topic I've ranted about for a long time on many occasions. I don't know if people can link you to something on YouTube. This video that we're about to watch an excerpt of does a fair amount of ranting about why C++ is bad for game programming. It's different reasons than what I would give because they're kind of optional, but they at least would tell you one thing. How many programming languages would I say that I know? I don't know. It depends on what you say, what you consider knowing a programming language. Like, I don't really know any programming languages that well. Like, I've used C++ for 20 years, but I ignore most of it because most of it's stupid. So if somebody gave me a C++ test, I probably wouldn't do very well because I don't know how most of it works. I probably would do okay on a C test, but not a modern C test with all the weird stuff that they've added. So, yeah, I don't know. I probably don't know any programming languages. Yeah, that Game Lab video is not a bad intro. Like it doesn't go into depth on specific C++ features that are bad, but it gives an overview. I should have thought of that. It's a good point. It's a very recent speech. And if you show that to your friend will have some idea why I don't think C++ is good for most programming, not just game programming. Is $1 a good price for simple 3D puzzle game that needs 30 minutes of gameplay to finish it? That is a question that you have to ask every individual who might buy your simple 3D puzzle game. It's not my job to say if $1 is enough or not. It's the job of people who might want to buy it for $1. Someone from Japan. I don't know. Okay, let's give it another 1 minute for people to show up since the view counter is still going up. And then we'll start talking. 1 minute. Hi from Poland. What do you do to get early access? You don't really. I'm sorry. You just have to wait till we're ready. Okay. I guess we'll get started. So this morning I woke up and there was a video online from RustConf 2018, which I didn't know was a thing, but that's a thing, where they talk about Rust, the programming language, not the game. And there was a video on there called Using Rust for Game Development by Catherine West from Chucklefish. And I watched it, and I have some disagreements with it that I'm going to want to talk about today. They're not... they're not internet flame bait caliber disagreements. Some of them people might think are pretty subtle, but they're important because they get down to the foundations of how do you want to program and how do you make sure your program is correct. And, if you're designing a programming language, how does the programming language help you know that your program is correct and all these things, right? And so I just wanted to go through and hit the major points of what I disagree with. I'll say, in the beginning, so that people don't get the wrong idea, I think that overall it's a good talk and that people would learn from watching it. It's just, there's just some things that I got to talk about. So let me, I'm going to bring the video up for a second. Oh. Wait, I can do that? I can toggle. Oh, let's just do this. Okay. So we're going to watch about a minute-long excerpt from it and hope that I don't get banned for showing a video. And we'll just use that as a starting point. But before we even do that, let me say, why do I care about this, right? So Rust is a programming language that I think has more of a reason to exist than most new programming languages, right? Like a lot of new languages are made by people who just are making essentially small stylistic changes to things that already existed, right? And the small stylistic changes, in the best case, could reduce friction and make things better, but usually they're just randomizations and don't make anything better. And they don't really solve real problems usually, right? So what Rust is trying to do is it's trying to increase software quality overall while, by, I'm trying to figure out the most charitable way to say it. By forcing the programmer to do things in specific ways that are supposedly more safe, right? And I'll say supposedly because this is going to be important later. And how does it do that? Well, and without taking a big performance hit for that, right? So a lot of languages that are predicated on the idea that memory safety is very important are garbage collected languages that don't let you poke at memory, and Rust doesn't do that, right? So it's more in the direction of things that I think are a good idea, where instead of having memory be managed for you, it's just, there's like a permissions model. There's a statically analyzed or compiled time enforced permissions model that determines what you can do with various pieces of memory and what you can't. And it is by nature overly restrictive. So there are some things that you could do that are correct that it won't let you do because it can't prove that they're correct, right? And so that's the basic idea behind what that language is doing. And part of the thesis of this talk is like, well, at first you have a hard time dealing with that stuff, like the borrow checker in Rust. You fight the borrow checker and it's very frustrating, but it's good because it then pushes you into patterns that are better anyway. And part of this talk argues that object-oriented design is not very good, and then this other thing is better. I certainly don't disagree that object-oriented design is not very good. Most people with a clue these days pretty much have done enough programming in that way to see the way it's bad and the way that it doesn't work. So I'm not, I have no argument with any of that. And in fact, the first disagreement that I have with this talk is something kind of subtle. So let's just talk about that for a little bit. Let me make sure my desktop audio is all the way up, and I'm going to be quiet, and we're gonna listen for a second.
Our internal states. I have this, I'm going to use this a lot, and this is going to end up being important, but there's this entity index type. And this is actually really interesting because this is super common in C++ game engines. In fact, I've never seen a systems programming language kind of game engine that doesn't have these. And this is a C++ example. So you might think like, okay, well this field is player ID. So like, Starbucks a multiplayer game, you need to keep a list of all the entities that are a player. But why don't you use a pointer? It's C++. We can live dangerously. Let's keep a pointer. And the thing is that nobody does this because it's wildly unsafe. If you keep internal pointers, they will become invalidated and your game will crash. So nobody in the systems game development environment, all game engines have this, it's either an ID or some kind of index or something to identify entities. And this is important because we have to do this in a lot of places in Rust, but it's the best idea. And it has other benefits like, for network serialization and file serialization. It's hard to serialize a pointer, right?
Okay. So let's start talking about that. It's completely correct what she says, that this is a pattern. Well, I haven't done a survey of all game engines in the world anytime lately, but what she described is basically the way that I do it, and probably the way that nearly everybody does it. And in case you don't program game engines, which I assume most people on the stream don't, I'm going to explain in a little bit more detail the problem that she's talking about, right? So the problem is that in games, oh, yeah, I guess I could enlarge the webcam since I'm mostly just talking. I don't want to be too big. Okay, we're going to be, let me just, I'll put myself up here in a contentious place so that, wait, what just happened? All right. So, you know, you can still look at this code. What I'm saying is not going to have much to do with this code because I think there's other things. There's some things that are misleading about this code that is shown here. But anyway, the basic issue with game engines that happens in all games is that entities want to be able to refer to other entities, but entities are also transient, right? So let's say you have a game full of little people and one person wants to follow another person around. Like there's some piece of code that's like, or there's some script trigger that says, this makes person A follow person B. So person A has to have some kind of reference to person B about who that is. And then maybe every frame, person A runs their update code and says, am I following someone? If so, then, you know, get the vector from my position to their position and so forth, right? So that's very, very common. Okay. And so what she's describing is the following scenario. So person A gets, let's say you do this the naive C++ way, where, you know, person A is an object and you created it with new, and so is person B. And then on person A, when you say, who am I following, you have a pointer to person B, right? And we'll talk about what the modern C++ people would say about this in a minute. But that's the naive C++ way, like every year that you would do it until 2015. And well, the problem is, of course, that person B could, you know, just get destroyed for whatever reason. He walks into a teleporter and disappears out of the universe. You know, gets blown up or something, or replaced by something else. So when that happens, the default thing in C++ is just that person A doesn't know that person B got deleted, and person B's memory no longer exists. So then person A comes along to run its update function, and it says, let me follow person B, and let me go look for the direction vector, right? Or get the direction vector between B's position and my position, right? Now, B may just have been freed and still have the same memory that it had because nobody's reused that memory. The memory could be reused by an arbitrarily different object, however, right? So when you go to read the position of B, you could get garbage bytes back in the form of floating point numbers and then be doing math on like some garbage numbers or some nans and get a really terrible result, right? Possibly even worse, or maybe not quite worse, for reasons we'll talk about later. The memory could even have been unmapped by the operating system. Like, oh, we freed this, and that was the last part of this one page that's been used, and now the page is no longer needed, so we're going to deallocate that physical page and so forth. And then if you try to reference B's position, you just get a page segmentation violation, right? And your program crashes. So just like you would if you were dereferencing a null pointer, right? So that's really not good. And it feels really bad for that to happen. It's a really ugly kind of a bug because your whole program just dies for what seems like a small mistake. And it's even more ugly because often in release builds, you might not see this bug for a while, right? Because maybe that memory is still valid because nobody's reused it yet. And then maybe it takes a long time to trace from the symptom of the problem all the way back to the actual cause of the problem, because the cause of the problem is that B got deallocated a long time ago and it's so far removed, right? Now, the modern C++ people would, of course, say like, oh, use a smart pointer. You should never use a raw pointer or something. But that's actually naive for several reasons. One reason is you don't want to use a regular reference counted pointer. Because you're not, like, person A is not authorized to keep B alive, right? So like keeping B alive with a non-zero reference count is also a bug. That will be hard to trace down in many cases. And then, well, there's other things you can do. We're going to talk about one of the other options in a minute. Anyway, so what she says is everybody does it this way, where you have an index. So what she's saying is everybody, instead of having a direct pointer, has a system where you have some kind of small and inexpensive identifier for an entity. For example, an integer index. That's what we had in Braid and the Witness. Every entity was just an integer, right? In one of the new games, it's actually two integers bitwise ORed together, but it's the same thing. It's essentially an integer. And that's a cheap thing. It's easy to copy. It's easy to look up in a hash table or an array. And then if so then every frame person A says, hey, entity management system, give me back the pointer to the entity with the ID of B that I stored when I started following B. And the entity management system will either say, okay, here's the pointer, or it'll say, no, it's gone, right? Now, when A looks up B and the core system says, no, it's gone, because A knew that it was mapping from an integer to a pointer, and because it knows that that mapping might fail sometimes, the code there will naturally handle this case. So you won't, in general, make very many errors that way. And that's why basically everybody does it this way. I think she implies in this minute of speech that we just viewed that that's the only way to do it. It's not really the only way to do it. So there are two other ways this morning that I thought of to do it, one of which I tried in the past, and another one which I never tried, but which I'll explain. Because back when I started a game company in 1996 and we were building a game engine, we had exactly the same problem. I had to learn my way through what is the best way to do it, and we had to try several solutions, right? So another solution to this problem, aside from looking up an integer index all the time, which you might not want to do because it's expensive, right? Or seems expensive. It's not really, especially, well, I don't know. It's less expensive than some other options. But one alternative that you could do is, well, instead of just deleting B and freeing the memory right there when B gets destroyed, then maybe B lives for an extra frame and is flagged so that it's flagged, B has been destroyed, but the memory is still valid, right? So then you could still have a pointer to B on A, and then A's job every frame when it checks, when it does something with B, its job is to check to see if B has been destroyed, right? And if so, then nullify its pointer, right? In principle, that's faster. In principle, it's simpler, but it's actually slower and more error prone, right? So the reason it's slower is because if B only lives for one extra frame or n extra frames, then any entity that has a pointer to B has to check and possibly clear that pointer within that remainder time that B is alive and says that it's been killed, right? So if that's one frame, then every entity has to run its update every frame to check to see if the guy it's following has gone away. And the more entities you have in the world, the slower that is, the worse it is. You don't want, so you might think, oh, just a simple update function for an entity, if that's all it does in the fast case is check one pointer, isn't that really fast? And it's like, not really, because the memory for most of these entities is cold. You're like visiting the entity. You have to get its memory into cache before you could even run its update function, and that ends up being one of the slowest parts, right? So in a relatively non-dynamic game like The Witness, where most of the entities are static, at the beginning of development, the theory was, well, we can just let all these entities update every frame and we won't have to worry about it because there aren't that many dynamic entities. Well, by the end of the game, about a year before ship, I had to write a system where entities would sleep, and not run their update function until they get woken up by something, simply because it mattered that we were running updates on, however many. It was a small single-digit thousand number of entities, right? But that was too much, especially on game consoles, which perform worse under conditions of large volumes of random access to memory than PCs do, right? So that is one alternative solution that you might think of. Okay, so that's the reason why it's slower. The reason why it's error prone is just, if you've got a pointer to an entity on your entity, you might just forget to check if it's killed, right? Because why would you remember that? There's no explicit step that reminds you. When you have to map from an integer to a pointer, that mapping is the explicit step that reminds you that the pointer you get back might not be good. But if you're just going to use a random pointer that's like on a member, it's very easy to forget to check, right? And then you have the same fail state. You have the same problem where the memory is deallocated and you don't know why. Like the symptoms of that solution are not any better. And that's why I think nobody really does it. Those two things together, right? The third thing you could do is some kind of a weak pointer system, right? Where on A, you say, okay, I'm following B. I have a weak pointer to B. And I can start just using that pointer arbitrarily, but I have to check to see if it's been nullified by an external system, right? So a weak pointer is something that'll turn null later, but it's not my job to turn it null. It's the core system's job to turn it null, right? And so what does that look like when you program that? Well, the system has to know who is pointing at B, and that could be a large number of people potentially, so there has to be some arbitrary amount of dynamically growing storage that stores pointers back to people who point at B, right? And you have to go nullify all those guys, right, when B goes away. But then, the guy who is pointing at B might go away first. So then you have this accounting in that direction of removing his pointer from the weak pointer list if it's no longer needed, etc. That gets complicated, and that has performance implications, right? And I think something along those lines is what the modern C++ people would advocate these days. I don't know exactly which std : whatever they would say is the right solution to that, because I just don't follow any of that stuff. But it would be something in that direction, right? Well, there are two problems, right? One problem is it's less performant and it's more complicated. And even if you didn't write the code, that code and that memory is still happening all the time. And that complication is in your system and you will have to deal with it, right? So that's thing number one. Thing number two is, again, there's this ambiguity. Like when you start, if it's a totally transparent weak pointer, if it's one that you can just like use and then maybe you have to check it for null once, that's a little confusing. Like, when can it be null? I mean, I guess it can be null only at the end of each frame. But if I have a bunch of methods on my entity, I guess I have to check it every time or at the head of each method, because I don't know which ones are going to get called from what entry point, especially as my code gets refactored. And I might forget to check it for null because, again, there's no signal that I should check. There's no step that reminds me that I have to check, right? And so I'm going to forget to check. So then what happens? Well, I'm designing this weak pointer system, and I want to ensure that people don't forget to check. So, well, what do? You have a getter on the weak pointer. The weak pointer itself is not something you could directly use. You call like get pointer value on it, and that gives you a pointer that you can use for the body of your procedure, and you better not store it in a data structure because you're a bad citizen if you do that. Okay, by the time you do that though, the access pattern in code looks exactly like this one here, except it's got all the added internal complication of this weak pointer system that this one doesn't need to have, So in general, you know, the version that Catherine is saying everybody does, I think most people do. I think some people do a weak pointer version. I've heard of that being used, but I don't think that's very popular because it doesn't really have any advantages. So she's very correctly saying the right thing here, which is like everybody does this. It's the right way to do it. Okay. However, now we get to what I disagree with. So what she says, I'm gonna paraphrase, but she says that nobody uses the pointers because the pointers are very unsafe and will get invalidated, right? What they're pointing to will no longer be the right information and you'll crash, okay? That is correct. But my problem is that that's not actually the problem. That's not actually the bug in the program. It's a symptom of the problem in the program, right? And this may seem like semantic nitpicking, but it's important. I'll try my best to explain why it's important, right? So the symptom is, hey, I've got a pointer and it doesn't map to anything valid anymore, but not necessarily consistently, because sometimes the memory happens to have the right content still, and it's really hard to debug and wastes a lot of my time. Okay, great. Not great, but yes, accurate. Okay, but the real problem is that for the system to be correct, work has to be done in some fashion to coordinate the fact that entities can be destroyed with the fact that people want to refer to other entities, right? That cross-referencing has to correctly happen. When that doesn't correctly happen, that's the bug. And then the symptoms of the bug will vary depending on which solution you do, right? So for the transparent weak pointer version, the symptom of the bug, well, it's slightly different bugs every time. But for the raw C++ pointer version she's talking about, the symptom is probably a crash or some kind of Heisenbug, right? And the reason this solution she's talking about is preferable is that it happens to be the simple solution that doesn't really provide an opportunity to fail to do that coordination, right? Because you have to do that coordination. The act of looking up this ID is the act of doing that coordination, right? And so again, the problem is a coordination problem. The symptoms of the bug will be different depending on the implementation. So another possible symptom, if you do the weird solution I was talking about that nobody really does, where entities hang around for extra frames, no, let's not talk about that one. If you do the solution, the naive modern C++ solution that I briefly mentioned, where like, hey, you just have smart pointers, right? Then the bug that's going to happen is going to be different, right? So A is going to have a smart pointer to B. It's going to be like a shared smart pointer. And then the system is going to have a shared smart pointer. And the system dereferences or reduces the reference count on B, but A doesn't. And now there's kind of a leak accompanied by this weird situation that A thinks B is still live when B is not live, right? So that's a different symptom of the same core problem, that the coordination was not done correctly, right? You might say that that symptom is better because you don't crash necessarily, although you probably will crash as those bugs pile up and the behavior of your system becomes weirder and weirder, right? Oh, and also, it's the reason I hinted at the beginning is that maybe it's not so bad to have a crash, is that crashes at least signal to you very clearly that there's a problem, during development anyway. Like, you hope that they don't make it into release, right? And so crashes actually save you time a lot of the time. If if you have a good enough programming culture that you don't ship builds to the content people that have a lot of crashes in them, right? Worse than a crash is a silent failure that's going to corrupt your behavior of your game or data on disk for like weeks before anybody notices that the data on disk is subtly wrong in places, right? That's really horrible. And that's what happens if you don't crash, right? So crashes are not necessarily as bad as you think. Okay. So we're not going to watch any more excerpts from this. You can go watch the whole talk if you are so motivated. It's about 40 minutes long. But she eventually goes on. So one of the theses behind the talk is, look, the Rust borrow checker is good because it forces me to lay things out in this data-oriented way where, you know, I've got components in arrays and so forth. And I'm going to skip commenting on entity component system. I don't like entity component systems. Whatever. If you like them, fine. Not the subject of this rant. But the solution that she ends up advocating is, you know, have, I forget what they're called in Rust, vec, I guess, which is annoying. They inherited bad C++ nomenclature, but vec, as far as I understand, is an automatically expanding array, you know, that you can put stuff in and it'll get bigger. Like everybody uses those today in modern programming. It's a workhorse of programming, right? And what she says is, well, look, you've got all these components that primarily consist of data, and you'll have an array of physics components and an array of humanoid state components and whatever else. And you just, it's like what I used to call a refrigerator. I don't know if people call it that anymore. Maybe they call this a pool. I don't know. Names for this change, but because all the elements, it's basically an array of memory. And because all the things that you're allocating and deallocating there are the same size, then memory allocation becomes almost trivial, right? And so she says, hey, just have an array of these components, and then we're going to use this generational index thing to determine if the slot that you're looking at is the one you meant to or not, which is actually almost another way of solving that entity coordination problem that we talked about, which is kind of interesting. Okay, but what she says also is, hey, when you're doing this, the reason you need this generational index is because you could accidentally be pointing at the old thing, right? And it's safe because it's memory that is valid, but it could be old, right? It could be stale. It could refer to an entity that's no longer live. Now, she's saying all this stuff from a very Rust point of view, right? So she said, in the part that we watched, she said, oh, it's unsafe to have these pointers here because you could crash or because you could reference memory that doesn't exist, right? Or you could reference memory that's not the right memory and corrupt some other part of your program. And she says, oh, this array version is safe, but it's not really any safer. Because here's the funny thing, is she's saying that the borrow checker forced her into much safer programming. But what she ended up doing is actually implemented her own memory allocators as these vectors of data structures. And then the reason why Rust isn't giving her a big argument about what she's doing with them is because the Rust compiler doesn't know that those are memory allocators. So there's no borrow checker activity on them, right? So it's this weird thing where it's like, it seems like a little bit of Stockholm syndrome to me, where it's like, oh, the borrow checker is so good because it made me program in this certain pattern, but then the real reason that the borrow checker is not complaining anymore is just that I managed to turn it off, but I didn't realize that that's what I did, right? This thing, let me see if she has a slide later. I don't remember at what minute. Oh, she gets a little too factory here, but there's a place where she talks about this. Yeah, so she's like, hey, my game state is going to have just a bunch of these arrays of all these things, right? Of each component type. Well, this is basically a custom memory arena that arena might mean the wrong thing depending on where you come from, but a custom memory allocator where, you know, there's either a physics component or not in every one of these slots, right? Now, why does that seem safer? Well, first of all, because the memory is never going to unmap, because the whole vector is, or vec, it's not a vector. The whole vec is not going to shrink, probably. I mean, I don't know why you would make it shrink. I could sort of imagine why, but you probably wouldn't make it shrink. And so therefore, you are guaranteed to be referencing memory that exists. But that memory is not going to be correct if you make a mistake, right? And that is exactly the kind of thing that the borrow checker is supposed to avoid. Now, I said earlier, I said this is going to sound nitpicky, but it's actually not, that there's a difference between the actual problem and the symptom, right? And this is where this is important, because the actual problem here is the same. You actually just kick the can down the road. The problem is still, I might have an allocation and somebody pointing to it, and that somebody might not correctly check the thing if they don't do it quite right, okay? The symptoms, however, are less dramatic. And the reason, though, is not really anything architectural, right? So this is the core thing that bothers me about this talk is she says, hey, you know, the borrow checker pushed me into this architecturally better thing. And I don't think it's better. Like, the reason the symptoms of the problem are not as bad anymore is just that you've refactored your allocations so that you're storing everything of the same type. So, you know, the reason sometimes that things get ugly if you reuse memory accidentally in the wrong way is that, you know, earlier there was a floating point number in this slot, there was a pointer in this slot, but that memory has been freed and now some floating point numbers got wrote there instead, but I still think it's a pointer, so I'm going to read that pointer and try to use it, and I'm going to crash, and that's a very ugly seeming thing. Although, as I said, crashes are maybe not as bad as you think. Well, that doesn't happen here, but it's not because you're architecturally better. It's just because you removed one physics component and you put another one there, and they're the same type. So the pointer slots go into the same pointer slots, and the floats go to the same floats, and the bools go to the same bools. So you don't have that kind of data misalignment problem. So it seems less ugly, but the problem is still there. It's still there. Now, in the process of doing all this, you know, in this version of Entity Component System, she formalized a way of referencing these things where you use that generational index, and that's a pattern that avoids this kind of a reference, right? But the data storage is not really the architecturally better thing. It's that pattern of, I know I'm using a certain index type to check the thing, and that index type will tell me whether it's still valid or not, right? Now, the reason that doesn't happen on a general heap as easily is because on a general heap, allocations are not really the same size. So, like, you know, you can't look at the first byte of the allocated block or the byte before it or however it's implemented or a parallel array. You can't look at that and ask, what generation is this or something, because you don't know if that's the first byte in the block because the sizes shift around inside a general heap, right? So the fact that these things are all the same size makes it possible to do that generational index thing. But what I'm trying to get at is that the borrow checker didn't help her solve the memory allocation problem, really. It made her kick the can down the road to the point where the borrow checker got confused and couldn't tell that she's allocating memory herself, right? And so she turned off the borrow checker manually and then made her own system that tries to make it not error prone, right? And so it's hard for me, in this speech, she credits the borrow checker as being really beneficial. It's hard for me to see that it's beneficial when really what you're doing is finding a convoluted way to turn it off and then doing a pattern that you would do in any other programming language. All right. So I'm starting to rant and repeat myself at this point. Let me look at my notes for a second to see. Well, I've been ranting the whole time, but I've been starting to repeat myself. So I think I've said everything that I want to say. So again, I don't want to come across as too critical of this talk. When people implement new systems and new programming languages, that's a good thing. Rust being a very a programming language that has a strong, well understood philosophy about what it's trying to do is a good thing, right? Of course, I'm designing a language that's different from Rust. I disagree with the overall goals of Rust as being the right thing for game development, which is why this is on my mind. But one reason why I'm looking at things like this is I want to know, like, even though I don't want to program using the borrow checker, at least not most of the time, maybe I would like an optional borrow checker to turn on sometimes, but I'm not sure that that's possible. Even though I disagree that that's the right trade-off to make in terms of where you put your effort when programming, I still want to know, okay, if I'm going to say that a good language design in 2018 for games doesn't have a borrow checker, then if I'm going to be a good engineer, I have to know the cost-benefit analysis of that decision, right? Whatever is good about the borrow checker, I should at least be vaguely aware of that I'm giving that thing up in order to do a design that doesn't have that, right? And so that's what I'm doing, is I'm just watching this and I'm trying to think very critically here. What is she really getting out of that borrow checker? And in this case, I actually am not seeing concrete architectural benefit. Not very much. Now, it could be good in the fact that, like, hey, it just forced me to explore and do something differently than I would have otherwise. But, and again, maybe my entire rant here is wrong and there's some reason why this is actually correct and doesn't just amount to turning the borrow checker off invisibly, but I'm pretty sure it is. I'm pretty sure it's just turning off the borrow checker invisibly, fooling the compiler. And so, okay, you could make the following philosophical argument, that it's not really fooling the compiler, because even when something in this array is deallocated, it's still a type-safe interaction, because you know that whatever data filled that slot was that type. It's just stale, wrong data, right? You can make that argument. Maybe there's something to that. Again, it may not all be positive, because like I said, having a strong symptom like a crash is often good, right? It helps you. So, yeah, maybe somebody from the Rust community wants to tell me why they think this is really good. I can see a little bit of a case for it, but it doesn't seem like a very strong case to me. It doesn't seem like a case that's so good that I want to spend that much time and effort, convincing the borrow checker that my program is good. But again, I could be wrong. So I'm not trying to flame war this. I'm not trying to say, oh, these people don't know what they're talking about. I'm just trying to putting my opinion out there in response to this thing that I saw, and we'll see. I mean, maybe I would be happy if somebody could come back to me and say, no, this is not really just turning off the borrow checker because, etc. And then I would really learn something. I think I just learned a little bit in the fact that I had to think about the nuance between, this thing is a deallocated version of a different thing of the same type versus its data of any type. There is a difference there, right? I'm not sure it's an ultimately very meaningful difference, but it is a difference to understand and be clear about. Okay, so that's the rant portion of tonight's stream. Does that make sense? Do people have questions about that? Philip Trudeau, how do you map entity IDs to pointers in a simple way other than generational indexes? Do you binary search through an array of entities? In the witness, it's literally just an array index. I think it's actually an array index plus 1 for some stupid reason. Like, we literally just subscript the entity array by that number. I think that's the way it works in Unity for components as well. It's just an array index. I don't know Unity that well, so correct me if I'm wrong there. There are other ways to do it. So in the Sokoban game, it's actually a hash table, and that's because our indices, like I said, we're ORing two things together. Our integer ID in Sokoban is like a user ID in the top 8 or 10 bits, and then an entity serial number within that level in the bottom remainder of the bits. It's 32 bits total, so the bottom 22 bits. So you don't want to make an array of those because that'll be a really big array, right? Because the high bits are set. So we use a hash table for that. Devender says, I stand by what I said earlier. It's like saying that the GC is good because it encouraged you to dodge the GC. Yeah, maybe. I mean, definitely with the GC version of that argument, that is clearly to me full-on Stockholm syndrome, like 99% of the time. In this case, I'm not sure because I don't understand the Rust borrow checker case as well. Like I've programmed in garbage collected languages. I've implemented garbage collected languages, right? I know some things about garbage collectors. I've implemented different garbage collectors of different types, right? I've never implemented a borrow checker system or a static analysis system that's that hardcore. So I don't have as clear of a picture into that. And I haven't programmed in Rust, really, aside from super trivial Hello World programs. So I cannot claim as much visibility into that. But it did, while I was ranting, I did think of the GC analogy that you mentioned as well. Hypernewbie says you can also zero on dealloc and crash with better error message of that type. Oh, totally. Like, well, in Visual C++, for example, the default or the debug version of the heap, when you call free, will overwrite the memory with oxcd, which is never going to give you a valid pointer. And so it makes things crash very easily. Or if you get wacky numbers because you're referencing scalars, you look at them in the debugger and you say, oh, that's oxcd. It's a cleared memory. Now, the hard part from there is to know who freed the memory and when, and then to understand why that happened. But, that's... And the real problem there is that all the tools that people made to help with that are not necessarily very good. Although maybe ASAN now and LLVM is good. I don't know. I haven't used it in a long time. But usually all the stuff like Purify in principle was a really good way to find that kind of a bug. But it lost its focus on C++ and it became like a managed language thing and got slower and slower and more horrible, and it's kind of unusable now. But like with a good tooling, it wouldn't be such a hard problem either. In general, what's the issue with generational indices as a solution to the coordination problem? Well, I'm not necessarily saying they're a bad solution. I'm just saying that they don't have... I'm just saying they don't make the problem go away. Like if you forgot to use your generational index and you just reference the array by subscript, you would get old data, right? And so in the same way that the entity index system works, because looking up the index reminds you that the result might be null. Or, in Rust, it would be an option type, and so you have to probably peel off the option anyway. So that's a way in which Rust is more strongly typed. But in reality, like in C++ even, you don't have this problem very much where you like don't check it against null because you know when you look at the thing. So option is like just a way of really ensuring that, which again, I don't necessarily have a problem with. But the generational indices are a step that you have to do to make sure you get the right thing out of here, right? I assume that she's got some procedure called like lookup component by generational index. I don't frickin' know what it's called, but right, but like it looks in this array and looks at the generation part of the index and makes sure that it's the right one. If it's not the right one, it returns nothing or whatever it's called in Rust, right? So that's all fine. That's a totally fine solution. It's just that what that is a solution to that coordination problem that I was talking about. A slightly different form because it's the component in the array form as opposed to the like live entity version, which is probably not different in deep principle, but let's say it's much older than entity component systems and is something that you have in the object-oriented world as well. I already answered it. Sorry, I can't disregard the question. You like my approach to language design? Reminds you of Go. Let's start simple, and if things need to be added, let's talk about it. Yeah, totally. I'm trying to be very experience-based. That said, the language I'm designing is more complicated than Go substantially, but that's because I think that those complications really help. I don't think you want to program using the simplest thing. You want to program in the way that's most ergonomic, which means that complications that help you are worth their weight in complication if they help you enough and don't cause big enough problems. And then, part of what I'm doing is, one of the reasons we're using this language heavily and we're writing a big program, right? It's 90,000 lines now. The reason is so that I can know for sure what is really a pain point and what isn't, in this new language. Brian Cantrell was talking about how the borrow checker was able to help the compiler prove that some pointers won't alias and generate better code. Yeah, that could be a good thing, for sure. Totally. The borrow checker here ensures that the vector itself will not go away while a direct reference into it exists. It does not ensure that an arbitrary index is valid. Those get bounds checked on access. It's a memory safety feature. Okay, but in reality, that is not ever going to happen. The way that these games are structured, these vecs will never go away while you're using them. It's a de facto not a problem. And so if you put the programmer through pain, daily friction in order to solve this problem that doesn't exist, that's a negative. Okay? See what I'm saying? It's a net cost. Now, that may be balanced by net gains elsewhere. For example, maybe the borrow checker finds some other bugs automatically that would have been very costly to find, right? Or maybe there are performance benefits, as someone was just mentioning. Then maybe those can balance it out to be a net gain, right? I don't know. I'm simply, I don't know enough to firmly bet a lot of money in one direction or the other. I'll just say I'm not convinced. I'm not convinced. When it comes to, I'm not convinced when it comes to the idea of net productivity, like how much functionality do I build in how much time or how much money, right? If you're going to say, my metric is not how much it costs or how long it takes to make it, my metric is the overall quality of the final program, how bug-free is the final programming, then I'm willing to bet that the borrow checker is a net gain, probably. But it's those other things. I think the cost, like I have several times built games where I barely managed to finish, right? And like, especially with The Witness, if The Witness had taken a lot longer, either we would have gone out of business or it would have been a worse game. We would have had to cut a lot of it or something, right? So I've just experienced that too many times to want to increase friction. I need to decrease friction, right? So that's where I come from on these matters. Thoughts on Chronos formal memory model and how it may or may not affect game design? I have no idea what the Chronos formal memory model is. Is that something for Vulkan? What is that? Have I seen Go 2? Not really. I haven't looked at it. Do I have a particular way that I'm currently solving this problem of destroying entities and making sure everyone checks? Yes, I do. I do exactly what she's talking about. You might not have been here, but if you play back this video starting at 11 minutes, for 1 minute, she'll explain exactly the thing, which is just you have an index and you look up the index before you can do anything with it. That's what she does. It's what I do. It's what almost everybody does. It is probably the best solution for current concepts of what a game engine is. Will it be a good idea to write a scripting language on top of the new language, or is this not useful? I kind of feel like scripting language is an old idea. Like, unless you're talking about visual scripting, like blueprints in Unreal or something, in which case I would say yes, because that enables people who are not really programmers to build functionality. But in the sense, in like the 1990s or 2000s sense of scripting language, I don't think so. I think they've proven to be all bad. Like, you still need to be a real programmer to program in a scripting language. And by that point, why don't you just use a real programming language, right? So I think we know better how to do that thing where the level designers can make programming happen, and that looks like blueprints. It doesn't look like a scripting language. How in the witness did I ensure that pointers were never held across frame boundaries? We didn't. It's just, I mean, the way we ensured it is everybody has to remember, don't put an entity pointer on a data structure that persists. And if somebody made that mistake, usually it was because they were new on the project and it caused a bug early on and we explained it and then it was fine. For small teams, that's fine. For bigger teams, that kind of thing becomes more of a problem because as more people cycle in and out and don't know what to do, you have more of those bugs. And then as your code base gets more complicated, you have more of those general kinds of things that people have to be aware of, right? And so it gets worse as things get bigger. But in the witness, we did that. And also it was very obvious because every subclass of entity was called entity underscore whatever, like entity human or entity puzzle panel or whatever. And so if you had an entity on a data structure, you knew it by looking. Of course, now in the new language, we can write static analysis that makes sure that that doesn't happen. And that would be my preferable approach. And that scales to bigger team sizes because then new people come on the team and it's automatically checked. Yeah, it's exactly. So, in the early days, people were comparing scripting languages to stuff like C and saying, oh, they're so much more productive and I don't even have to declare my variables. I just use them. And then they started noticing all these problems like I can't debug my program because every time I typo a variable, it's the empty string, which is also number 0, right? So that's problem number 1, is that it actually was much harder to debug programs. But problem number 2 is that the reason productivity seemed higher in scripting languages is just that they had better built-in libraries. That's all. If you have a really good built-in library for C or C++, you're almost as productive as one of those scripting languages. Probably more once you include debugging time, right? And so that's where those languages fell down. Well, and they fell down in the performance area because it always started out like, oh, we're just going to have our gameplay code be in Lua. And you know, how much gameplay code do you run in a frame? Not that much. Most of the work is rendering. But surprise, surprise, inevitably, you end up being CPU bound by running your scripting code that's running all your gameplay code that's way more complicated than you thought it would be because your level designers are doing crazy stuff that you didn't anticipate, which is good because the part of the power of game development happens when you take away bottlenecks from people. So if you give level designers the ability to do complicated things, then the good thing is they will do complicated things. And the bad thing is that they will do complicated things. So very quickly, your scripting language becomes a bottleneck, and then you have to devote somebody to like factoring things away from the scripting language into C++, and that's a giant pain in the butt, and like, just forget it. You have a visual programming system. Where can you get a reference for us to support it? Well, when we release the language, we're going to have a very inclusive policy about libraries and how you get other people's libraries. So we're going to make it as easy as possible for you to get your thing out to everybody, right? We're not going to take the position that we are a central authority over whose code you should pay attention to, right? So you'll just be able to publish your stuff and people will be able to use it and it'll be good. Vulkan has just become the world's first graphics API with a formal memory model. I don't know. It sounds like overreach to me. It sounds like they already have too many problems. Why are they adding more? But whatever, I'll read the thing. Scripting language can be useful if you plan to add modding support to allow people to do stuff with ease. Yes, but they can do it with more ease with a visual script language than a text scripting language. You think borrow checker increases friction initially, but can decrease it overall in the long term. You start to naturally write code that passes the borrow checker, but it catches any mistakes you make. This can be useful for certain things, like use after free is caught at compile time, and you cannot get data races in multi-threaded programs. So you spend no time debugging those later at the cost of resolving them at compile time. Okay, I have two arguments with this. The first is, well, I don't really have an argument with it. Like, you start to naturally write code that passes the borrow checker. That's fine, but like, how much more work is it to write that code than it would have been to write the other code? And what percentage of the time do you still get dinged by the borrow checker, and how much does that cost, right? So that's my thing there. I don't doubt that you do get kind of used to it though, and the friction goes down, right? I don't disagree with that. But what I'm saying is even 10% friction more than I ever had would have killed me. I wouldn't have been able to make the things that I made. Even 5% more friction would have been really bad. So yeah. Okay, so the second thing, you cannot get data races in multi-threaded programs. I'm sorry, but that's complete horse shit. I'm not gonna let that slide at all, right? Rust people keep saying this. All right. It's true that you won't get data races in the subset of multi-threaded programs that use the concurrency primitives that Rust understands and can enforce safety on, right? And I'm sure, I don't know what those are because I don't program in Rust, but I'm sure there's like mutexes and stuff, right? And that's fine, right? Hey, you can write a multi-threaded program with mutexes, and it'll be checked. And that's great, actually. That's a very important advance, because in C++, as soon as you have threads, you really lose a lot of morale about program correctness. Okay, so I'm very in favor of a way to enforce that you don't use things badly, like out of the mutex that you should use them in or whatever. That's not my problem. My problem is the wildly overarching claim that you can't have data races in multi-threaded code, or the fearless concurrency thing that they say, which is, it's frankly horseshit. And the reason why is the following. Those concurrency primitives, like mutexes and whatever, semaphore, condition variable, whatever, are not the actual things you do when you want to write really fast code. The things you do when you want to write fast code are inherently unsafe. There are things like interlocked exchange, which maps directly to a CPU instruction, okay? And the reason, well, okay, aside from some very weird, I don't know where to start with the rest of this rant, but like, certainly in games, the reason you use threads is to get performance. If you're not interested in performance, then you probably shouldn't be using threads. There's a couple of other cases, like sometimes you're forced to deal with bad APIs or whatever, but the main reason in games why we do things asynchronously is to use the hardware better, right? There is a small subset of what we do for which mutexes are good enough. But once the problems get challenging and once your performance demands get high enough, mutexes are not good enough, right? You got to whip out the interlocked exchange and whatever, and Rust will have nothing to say about that because it can't. It can't analyze that. It has no idea what's happening at that point. And again, I'm not even talking about canned lock-free data structures, like a lock-free queue or something. I don't know if you can do that in Rust, in safe Rust. Maybe you can. I'm skeptical, but maybe you can. I don't know. I bet, so if you can't do it in Rust today, I bet with some number of extensions, you probably eventually could do like a lock-free queue, but that's not even what I'm talking about, right? I'm talking about problems like I have on the compiler where I've got this giant tree of nodes and I want to be able to individually lock individual nodes in order to prevent tearing on pointer reads, but I want to do that in the absolutely minimal way, and every node is orthogonal to every other with respect to synchronization, right? It's just not within the realm of what the Rust borrow checker can prove. And so on the one hand, awesome. It's great that you found a way to have more provability within a certain range of problems. But don't claim that you've solved the problem. That's either disingenuous or naive, right? I suspect it's kind of naive. I suspect it's just that because we're in this world where most programs are slow, everybody thinks that multi-threading will make you faster and mutexes is how you multi-thread. So if we prove things about mutexes, that'll help. It's not true. In reality, even once you multi-thread, it's hard to go fast, right? You get contention for resources all the time, all the time. You get these log jams and you're trying to make the log jams not happen. And that's really hard. And yeah, I'm going to stop the rant there, I guess, but that is what I think about that. So good that Rust is doing things in this area. If I'm doing new multi-threading, I probably start with a mutex, and I would like that version of the code to be bug-free, and that borrow checking may help there. But in many cases, I'm going to migrate away from a mutex to something lower level, and you can't prove anything about that. As far as I know, Again, maybe this is some area of my great ignorance and this has been solved, but I don't know. Okay, so for people who thought the previous part of this rant was too nice and insufficiently ranty, hopefully that was more ranty for you. For some reason, they still supported JavaScript and Unity until last year. Yeah, I don't know, man. I mentioned I don't enjoy entity component systems. Would I be willing to say more about that? You know, I really need to make a list of links to like the times that I've ranted about various things. Basically, I don't think the complexity of an entity component system is warranted. I mean, maybe if you're writing a general engine like Unity for a lot of people to use, you might do it. But like, dude, we shipped Braid without entity component system. We shipped The Witness, which is a pretty complicated game, without entity component system, right? It's over-engineering something that doesn't really need to be done, in my opinion. There are some designs of games that warrant it, but not very many. And even the ones that do, I would claim a different kind of view is possibly better anyway, I think, maybe. So your language itself doesn't define rules that keep programmers from using sharp tools, but you provide static analysis tooling to allow each team to define their own boundaries. Yes, that is the approach. Right now, that static analysis doesn't look very much like classic static analysis like Russ does or like other languages do. We might try to provide a library that does that, but the reason Rust is a pain in the butt to program in sometimes is that the static analysis is aided by what you type syntactically, right? So if you have a language that doesn't force you to type a bunch of extra info syntactically, there will be a limit to what the static analysis may be able to do, right? And I'm going into this approach knowing that, right? However, I think that is canceled out by the massive utility of just being able to do house rules, like I've showed in YouTube demos, or like I mentioned, like you can just say, nobody is allowed to have an entity pointer on a data structure unless it's this small set of data structures that are whitelisted, right? You can just program that very quickly, and then that's in your system. And that's maybe even better than borrow checker kind of stuff, because you can assert on things that would be bad for performance, right? Not just things that are technically incorrect, or semantically incorrect. You've seen some engines use a pair of integers for entity ID as an index to the entity pool and a unique serial, which is assigned to an entity at time of creation. When referencing if the pool slot is freed or whatever here is unmatching serial, the reference is considered stale. Yeah, that is isomorphic to the generational index that Catherine is talking about here. Tangentially related to your entity pointers answer, you've said that e.g. Facebook has abysmal productivity per engineer compared to small teams. Do you think your language would help productivity scale better with team size than it currently does with C++, Java, JavaScript? I think that it would, and again, it's because you can program in the house rules and stuff and customize them to whatever you want. However, I don't want to make claims about suitability at large team sizes because those are frankly untested, right? Claims like that should be based on empirical experience, and dude, the largest team that has used this language yet is like 4, right? So I don't have empirical observations there, but I think, yes, the design is amenable to that. Rust doesn't just provide mutexes, it provides atomics and other goodies that you may want. Yeah, I know, that still doesn't cover the cases I'm talking about, though. I should give my opinions on Rust's custom allocator API before it gets stabilized. I don't know enough about it. Too busy. You must understand the average programmer's idea of concurrency is a web server responding to requests in parallel. Yeah, I know. But that's the thing, like, okay, for that kind of concurrency, where you don't care that much about performance, I guess it helps. But here's the sad fact, right? Like, I could very likely sit down and write a single core web server that outperforms all of these parallel web servers, right? because because the software is inherently slow and it's log jamming on itself all the time. Like you just, I mean, I guess web servers don't log jam on themselves too much because they fork processes, but then they're all like, you know, talking to the same database or whatever the hell. And the database tries to provide concurrent access, but like you're going to lock a particular table and whatever. And nobody monitors that. Nobody profiles that. So like they log jam at some point pretty badly. If Russ type checker can't yet check those problems, are those limitations that just need to get implemented, or are those inherent in the design? Well, some of the problems, like I said, you could add extensions to check, but some of it, like, I don't know how you compare interlocked exchange or how you prove anything about that. It's like trying to prove something about adding 1 to an integer, and then some other logic in your program is gonna do something with that integer. It's like, you would have to have completely solved the program proving problem to do that. And I don't think we're going to be there anytime soon. Is the solution getting closer to the CPU again, less frameworks? I'm not sure what you were talking about there, but I certainly don't think it would be bad to have fewer frameworks, yes. Dr. Jeet says, I thought Russ doesn't prove anything about mutexes either. Their model is like C++, where some expert writes the thread-safe utility type that provides all the guarantees that the borrow checker expects, and everybody uses it. Well, that's what I'm saying. That's what I'm saying. Like, I don't know that much about how things are implemented in Rust, but the point is, for the borrow checker to tell you you have to be holding the mutex to access this thing or whatever, it has to know something about mutexes, whether that's built into the compiler or whether that's built into semantics that whoever programmed the mutex describes. It has to happen somehow. Again, it's actually, there's a coordination problem that has to happen, and the implementation details could be a little bit different, and I'm frankly uneducated as to exactly what they are, but you know the general shape that they have to be because they have to solve that coordination problem. Do I want to click on this? Log jamming. Yeah, I don't think I wanted to click on that. FYI, Rust has this thing called arc to safely send atomic reference counted objects between threads. Yeah, I don't think that's what I'm, you know, that falls into the category of what I was talking about as, you know, kind of like a lock-free queue or whatever. Although that doesn't sound lock-free, which might be bad. I don't know how that works, but I don't like arc in various programming languages generally for other reasons, which I ranted about in my speech where was that? In Game Lab Barcelona on YouTube, that maybe somebody can paste the link in, right? Arc is really bad for performance. If you use it in very limited cases, and you know you're only value copying from like one in-memory array to another one, and you're not making a bunch of stuff on the heap, then maybe it's not that bad for performance, unless it's not lock-free, which it probably isn't. But I don't like arc as a general language. Like I wouldn't make a language where I encourage people to use arc all the time like some of these languages do, because it makes programs slow. Those intrinsics are written in unsafe code, that is how. Yeah, and then, you know, okay, so there's some unsafe code, but it's unsafe code that you can't even reason about. Like some unsafe code is unsafe to be fast, but then you can write some things that helps you reason about it. But like just an interlocked exchange sitting out in the middle of nowhere in a program, what are you going to say about that? really. Maybe I haven't sat down to think about it. So here's the thing. Maybe you could say something about that. Maybe for a large subset of where you would use interlocked exchange, there is a facility that Russ could provide, and that would be good. I would be very much in favor of that, just like I'm in favor of having a good mutex implementation that you can prove things about. I object to the idea that like, oh, the problem's solved, right? No, it's totally not. It's totally not solved. When you were talking about level designers and scripting languages, it was as much of an issue when you were working on Deus Ex 2 and Thief 3. I don't remember it being an issue at that time. But I've definitely seen it happen on various games. Yeah. Okay, that was more ranting than I expected to do. We're at an hour and a half. I think it's time for me to go out and have some fun and relaxation, and maybe we won't do any programming now. Have I thought about language evolution? This is something that Russ and Unity's scripting team are good at automating, and C++ is awful at. What do you mean by language evolution? You mean upgrading your code to use more modern features? I don't know what that means. When you said that intrinsics are wrapped and unsafe, you mean the library does that and you call the intrinsics and build other things on top of them. Yeah, I mean, the thing is, for the use cases that I'm talking about, there literally is not anything wrapping the intrinsic. I mean, if you made a wrapper for the intrinsic, it would be nothing but enclosing the intrinsic, right? And so there's not a higher level structure to generally reason about, I don't think. But again, maybe I just don't have enough Rust experience to know how to somehow do that, right? Like if somebody wants to show me how to solve the problem that I mentioned in Rust, without a runtime performance impact, then I'll be very impressed, right? And again, that problem was you have a bunch of nodes like in a syntax tree for a compiler, and you want parallel access to all the nodes. But some people are writing to a particular pointer in the node, say, but that write is very rare and only occurs once. And I want to read the pointer, and I want to know if it's been written to yet or not. And I'll know that by whether it has a 0 value or a non-zero value. But if I read it, I don't want to get a torn write. So, well, actually, that's too easy because you could do that one with atomics. Like if it's really just one field, you can declare the field as atomic. Like even C++ could do that. So I would need to come up with a harder problem. So never mind. But this class of problems where it's like I'm using an interlocked exchange and it's coordinating with some totally other part of my program that also is using an interlocked exchange, and like we're in separate places in the call graph and all that. Like I don't see how you do it. I just don't see it. Maybe you can do it, but it feels to me like go-to in a structured language where people don't want to think about it. I don't know. Maybe I just don't know enough Rust. Language evolution like automated upgrading. Yeah, well, so our solution to that is just that you have enough information about your program at compile time that you could transcribe the entire program with all its types correctly. So you should be able to just have code that outputs the new thing. But we'll see. Well, there are plenty of async libraries and data structures on GitHub that you might see in something like C or C++. Yep, but that's not what I'm talking about. Again, it's hard to explain if you've never seen it, but the programmers who make the fast parallel code, like when you're at the point where you're like, I want to saturate memory bandwidth and I want to saturate, I want to ensure all the ports in my CPU are being used all the time, right? So I want to make sure the FPU is multiplying things all the time. I want to make sure the integer unit is adding things all the time or whatever, and not sitting there idle. When you're in that business, the primitives that you use don't look like the multi-threaded libraries that people provide. They don't look anything like that. They don't look like Go channels. They don't look like that at all. They're very low-level synchronization mechanisms that you use in order to do something very, very fast, in order to make a determination about whether a particular action is safe or not. Thoughts on C? Why would I talk about C now? You'd be surprised by the kinds of things people have created. It's not all just Go channels. Yeah, it's possible. Like I said, I don't have knowledge of that area. But let's just say I am strongly skeptical that, or I strongly suspect that the whole fearless concurrency idea is an extreme overstatement for the kind of concurrency that high-end game developers are in the business of doing, right? Let's just leave it at that. Okay, I'm going to go out and have fun. Thanks for visiting my rant. You can watch this speech on YouTube, RussConf 2018 closing keynote, if you want to have more context about what I was talking about in the first part of the rant. Thanks, everybody, for coming by. We will do some more programming sometime soon. Let's find somebody to raid now. Not Pokemon. Dude, there's a lot of people in the programming channel right now. Why is this guy always in the programming channel, but like Photoshop is open? What the hell? Is this a different guy? Like what? That's not programming. Come on, bro. I wish I could X out his programming. All right. .NET Conf. Okay, that's a no. Ranting. Minecraft modding. Speak up if you see something particularly great that is not JavaScript. Someone with an eye tracker, Zooter development. Oh, that's the Zelda test run. Yeah, that could be cool. Indie game, Snowball saves summer.
So we'll capitalize these things because they should be capitalized.
C#, it's not the worst. It's, a little too much Unity, but we could do that. What do people think? All right, nobody seems to be giving an opinion. Oh, let me check the Elite Frequent Flyer Secret Illuminati Lounge. Nope, nobody has said anything there since the start of the rant, or Discord is broken. Okay, let's do Snowball Saves Summer. And I'll see y'all later.
Work. Oh, right, but I need to do one more thing. I need to change this button here to do mini controller or map controller dot